As we talk today, we're all looking at comparing our scientific notation numbers. There's a lot of different categories to start to compare, so kind of getting an idea of what you're looking at is super helpful. Here we're just going to look at some examples when you have a scientific notation number and you're comparing it to another scientific notation number. And then hint number one that I'm going to say whenever you're looking at those and they're both in this version of scientific and scientific, hint number one is just simply check the exponents. We know that scientific notation is a way of writing massive exponents, and that's kind of might be tough to read, so let's just put that in black too. Check the exponents. Writing massive numbers or massively small numbers. So it's easy to get caught up and say, okay, we'll look at 7.62 and 8.94 and start comparing there. If you have them both in scientific notation, check the exponents first. The larger the number, the larger the exponent, the larger the number. The smaller the exponent, the smaller the number. So here, if I'm only moving my decimal spot 5 times, actually let me give me space to do that, 1, 2, 3, 4, 5, I'm guaranteeing that I'm not even in the millions yet, I'm in the 100,000s. But here, if I move my decimal point 7 times, 1, 2, 3, 4, 5, 6, 7, I'm inserting all those extra place values and I'm well over 1 million and into the 10 millions. So here I'm in the 10 millions, here I'm not even into the millions at all yet. So if you have scientific notation, check the exponents first. The bigger the exponent, the bigger the number. The smaller the exponent, the smaller the number. That's hint number one. Hint number two, when you're checking in, again, scientific notation versus a scientific notation number. So number one there, scientific notation. Number two, scientific notation. Compare the numbers, which is bigger, which is smaller. Here you have the exact same exponent. We're taking 10 to the 11th power as our decimal mover. So we have our base, 8.94 and 3.92, both are being multiplied by 10 to the 11th. So hint number two, if exponents are the same, well, then check the bases. Because now if we know that we're moving the decimal spot the exact same number, all that matters is how big is the base. So now if I know that this decimal spot is being moved 11 spaces, this one's being moved 11 spaces, I'm getting the exact same place value of my gigantic number, so all it matters now is that baseline number. 8.94 is bigger than 3.92. That must mean our number on the left is larger. So 8.94 is bigger than 3.92. 11 is the same, meaning the decimal point is moving the exact same place. So our bases, that has the bigger base, has to be the bigger number if exponents are the same. Hint number three might hit you as obvious, but just needs a reminder if we're doing, again, scientific notation versus scientific notation, and we are looking at really similar bases, very different exponents. Hint number three about which is bigger, positives are always larger than negatives. So if I'm taking my decimal spot in 3.83 times 10 to the 15th and moving it 15 places to the right, and I'm taking my decimal point in the left number and moving it 3 spaces to the left, I'm making this number crazy small, this number crazy large, meaning that if I have negative exponents, knowing that we're starting in the same spot with our bases, a positive number or positive exponent's always going to be bigger than the smaller exponent, or the negative exponent, I should say. So it might seem obvious, but a positive exponent will always yield a larger number than a negative exponent. Change the background color of this slide for a different way to compare. Here we are comparing scientific notation numbers with standard notation numbers. Biggest hint here is that you want to use the previous hint. So in order to do that, you have to convert. And when I say convert one or the other, but you want things in the same form in order to compare them. Otherwise, the numbers don't really make sense. So here, I'm going to convert the scientific notation number to standard notation. So if I know that I have 4.7 and I'm multiplying that times 10 to the 6th, that's 6 spaces to the right that the decimal is going. So 1, 2, 3, 4, 5, 6. And I place my zeros in those little valleys between all those peaks. Then I'm just going to drop in some commas to help me conceptualize what that number is. So here I have 4,700,000. I line that up with this number, and I just look at lining up place values. I got 3 zeros, I got 007, and and then I have a 4. Looking at those two numbers, it's pretty stark to see which one's larger. I see that top number is going at least 3 place values further than the bottom number. So I know that in this case, this is 3,894,000,000. In the bottom case down here, I have 4,700,000. So up here, I'm in the billions, where here I just got into the millions. So of course, the billions is going to be larger. So then this number here must be larger after I converted. If you didn't want to convert to standard notation, you can convert each one to scientific notation and then still use the hints from those previous when you're comparing two scientific notation numbers. So I'm going to keep this one, but then convert this one into scientific notation, then compare. So I know I'm going to place my decimal point between the first two non-zeros, knowing that I want my base number to be between 1 and 10, so 3.23. Then I look to start to turn the green number back into that blue, or excuse me, the blue circled number above. So now my instructions are going to be, okay, well, how can I turn 3.23 back into 0.000323? Well, I'm going to have to move my decimal spot 1 spot, 2 spots, 3 spots. Let's just double check. How close am I? Okay, I got to go 1 more in order to get all those zeros necessary. So now let's see how far I moved that decimal point. 1 spot, 2 spots, 3 spots, 4 spots. So this could be written as 3.23. That's a terrible color for this background. 3.23 times 10 to the 1, 2, 3, 4, negative fourth. If I'm now comparing these two numbers, I go back to my hint. And so now I'm looking at 3.23 times 10 to the negative fourth versus 4.8 times 10 to the negative fifth. And we said that the larger number, if we have both scientific notation, the larger exponent gives us the larger number. Well, negative 4 is greater than negative 5. Therefore, the larger number is right there, 3.23 times 10 to the negative fourth. And so again, using those hints that we had before, and so my hint back up here was to convert again, but this case, I converted both into scientific notation and then used those original hints to compare. So hopefully these help. Convert if you need to, compare those exponents if you need to. If the exponents are the same, check the bases, looking at how to compare massively, massively huge numbers or massively, massively small numbers.